Okay, so on Wednesday, we talked about the fact that there's the quotient rule. And if you don't remember the quotient rule tells us that if you have log of some base of m divided by n, then that's the same thing as saying log of base b of m minus log of base b of n. So really, what you can do is you can take this left-hand side and you can rewrite it as log of 2 of 24 over 3. Does everybody see where I got that? Okay. All right. Now, since we are good mathematicians, we're like 24 divided by 3. Well, I know what that is. That's 8, right? Yeah, hopefully, yes. Okay, and on this right-hand side, we're still stuck with this log of base 5 of x. Anybody with me?
Yeah.
Okay. All right, cool, awesome, great. Okay. So, what we can do now is we can take this log of base 2 of 8 and actually make it into one number. So, the way we do that is we take it and we write log of 8 divided by log of 2. And we're going to type that mess into our calculator. So, take a moment, type that mess into your calculator. All right, and tell me what you get. So, we get 3 when you type it into your calculator, right? Okay? So now what we want to do is we want to take this over here on the right-hand side, and we want to get it to equal 3. So we need to figure out what number will make this 3, okay? So with that being said, we're going to take each of these answer choices and plug them in. Yep, so we're going to take log of 3 divided by log of 5. Tell me if that equals 3 or not.
No.
No, it doesn't. It equals like 2 something, right? Whatever, okay? Now let's take answer choice G, which is 21, and let's plug that into our calculator, and let's see if that gives us 3.
No.
It doesn't. Okay, so let's try plugging in 72. Does that give us 3?
No.
Okay. Let's try plugging in 125. Does that give us 3?
Absolutely.
Yeah, it does.
You could have just did like 5 to the 3rd power.
So you just brought up a really good point. She said we could have just done 5 to the 3rd power equals 125. Why do we know that that would work?
Because you're plugging in 3 and then you're taking the log of 5.
Okay, so we know that we want this side to equal 3. Our base is 5, so we can go 5 to the 3rd power, and then whatever that equals, that would have been our x, right? So our answer is 125. Page 3, we're talking about change of base, okay? So on this first one, it says log of base 3 of 3.3. Now, this right here is in base 3, right? Like we can tell because there's a little subscript that says 3, right?
Right.
In the human world, in our world, we work out of base 10. Okay, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go 11 all the way to 20, and then we go to 21 to 30, etc. Right? Yes, no, that's how numbers work, guys. Okay. All right. So, sorry, that was a little salty. All right. So, what we're gonna do is, if I told you to plug this mess into your calculator, you would tell me log of 3.3 divided by log of 3. Now, the reason why we do this is we're actually changing the base from being base 3 to base 10. Do you notice how there's nothing written right here? This little, like there's no little base right here, right? So we're going to assume that if nothing is written for that base, it is 10. Okay? So really what this formula does right here is it changes it from base 3 to base 10. So go ahead and plug this into your calculator. Okay?
What is the button? Oh, 1.197.
Okay. Did you get 1.197?
I rounded.
Okay, shh, ready? So, if I plug this into my calculator, I get, and I quote, 1.086 or 87, because I'm going to round it, right? Okay, so I'm going to put 1.087. I'm going to round to the thousandths place. Guys, I don't care about rounding. Some tests say round to the thousandths place. Sometimes it says round to the tens. I don't care. Pick the answer that's the closest. Okay? Now, if you need to round up, round up. If you need to round down, round up. Like, y'all know rounding rules. I don't need to explain them. Okay? So this is change of base form. Now, go ahead and look at number 5. Look at number 5. On number 5, it says log of 3.55, right? That was it. Yep. Okay, so log of 3.55. Now, what is the base of this guy? 10, because there's nothing written here. So what you can do is you can actually type this directly into your calculator. So I'm going to go and say log of 3.55. Close parentheses, I'm going to hit enter. That gives me 0.550, right? Okay. If I, for some reason, forgot, hey, I don't have to do the change of base formula for this because it's already in tens, all I got to remember is that there should be a 10 right here. So if I put log of 3.55 divided by log of 10, and I put that into my calculator, log of 3.55, close parentheses, divided by log of 10. Look what it gives me. The exact same thing. It's like magic. So, you should never get these questions wrong. Like, you should never get these questions wrong. Okay? Because so these problems, okay? So, let's check your work. So, on number 2, what'd you get?
I got 4.907.
Okay? On number 3, what'd you get?
1.16.
Okay? On 4, what'd you get?
1.070.
1. Okay. 5, you got 0.55. 6.
1.4.
Okay. 7, what'd you get?
2.059.
8, what'd you get?
0.903.
9307. Ooh, that's rough. What on 9? What'd you get?
1.536. You might have put on 1.5.
You don't have to. You don't have to. Okay, on 10, what'd you get?
1.725.
Okay, 11, what'd you get?
1.1117.
12, what'd you get?
3.7567.
Okay, so that's what you should have gotten. That's what you should have gotten. Is you're going to actually talk to your neighbor in just a second, and I want you to read. Wait, in just a second. I want you to read these equations or these expressions, and actually rewrite it in exponent form. So I'm going to do the first one for you. So this says log of base 10 of 100 million equals 8. So I can rewrite this and put it into exponential form. So this is going to be 10 to the 8th power equals 100 million. Yep. And just like what you said, there's 8 zeros. So write out 8 zeros. Yep. What you said was, hey, take this, raise it to this exponent, and get this. So log of base 2 of 16 equals 4. That's going to be 2 to the 4th power equals 16. Log of base 5 of 2, or of 25 equals 2. So 5 to the 2nd power equals 25. And these are all true statements. Like, you can plug them into your calculator and get the other side, right? Okay? Let's go ahead and take a look at this table really quick. Take a look. Took a look. Okay? So this is in base 2. Okay? The last time we talked about a table, we were in base 10. Okay? In base 2, what you're going to notice is this right here, 2 to the 1st power gives us 2, right? Like 2 to the 1st power gives us 2. So if we took 2 and raise it to the 1st power, that's what our x is going to be, right? If we take 2 to the 2nd power, look what we get. And we also have a whole number over here. 2 to the 3rd power, look what we get, a whole number over here. Okay? So, in the last chart that we talked about, remember, the whole numbers were the only ones that were down at the bottom where it was tens. Yes? No, maybe. Yeah? Okay. All right, so when we're in base 2, our whole numbers are the numbers that are multiples of 2 in the sense of 2 to what power gives us that number. Okay, so let's go ahead and look at those questions down at the bottom. So it says, use the table to find the exact or approximate value for each expression. Then explain to a partner what each expression and its approximated value means. Basically, evaluate this mess. Okay, so what you're going to do is you're going to take this number, this big number, which is 2 on this one. You're going to go to your table. When x is 2, what was y? 1. Okay, so this is going to equal 1. Now, if you're like, I don't want to use this table, what you can do is you can say log of 2 divided by log of 2, and that equals 1. Or you can do it off the table. I want you to take a moment. I want you to evaluate B, C, and D. 32, and we know that that's going to equal 5, but let's look at the table really quick to like make sure that we know what we're doing. So 32 was the big number, right? And look at what our y value is. It's 5, okay? So log of base 2 of 15, okay? We can plug that into our calculator instead of using the table, and that's going to give us 3.9, right? The next one, that's going to be log of 40 divided by log of 2. What is that going to give me? 5.3. Okay? Questions on that? Okay, so let's talk about 2. Ready? Shh. Solve each equation. Write the solution in a logarithmic expression. So we're going to use the circle of life on this one. So we're going to say log of 2 of 5 equals y. Now, we got to solve this mess. So we're going to plug into our calculator, and we're going to say log of 5 divided by log of 2. What does that give me? Okay, go ahead and try B and C. Okay, so on this next one, if I write this out in log form, I'm going to have log of 2 of 70 equals y. So if I put this into my calculator, I'm going to do log of 70 divided by log of 2, and
6.129728307.
okay, what Jacob said. Okay, so then
6.13.
the next one, I'm going to write it as log of 2 of 999.
Isn't it 9.996? I put 10.
No, put 9.6. Yep. Renaya made a mistake. Is 9.96. Yeah, you told me 9.6. It's okay. Just want to make sure. Okay, so this says to rewrite in exponential form. So this already has a log right here, so we're going to write in exponential form. So we're going to do the circle of life ordeal, okay? And that's going to be 11 to the negative second power equals 1 over 121. That's it. That's all you writing down. Right now on a piece of paper. You're going to 7, go over here to the negative 3, and set it equal to 1 over 343. Okay? We go in the circle of life, and we're going to say log of 3 of 1 over 243 equals negative 5. I'm going to write this in logarithmic form. I'm going to do the circle of life. I'm going to say log of 9 of 81 equals 2. Boom, done. Okay? You're going to put this in your graphing calculator. You're going to say log of 216 divided by log of 6. When you put that in your calculator, you're going to get 3. Boom, done. You take this, you put it in your calculator by putting log of 1/4 divided by log of 2. That's going to give you negative 2. Boom, done. Okay?